Now let's discuss about radiometric quantities. Let's see the different quantities which are quantitative parameters important in measuring the radiations. فإذا هلا بدنا نحكي عن مجموعة quantities عن مجموعة parameters. We will define these parameters. بدنا نشوف الايكويشن لهدول البارامترز وشو بيعطونا معلومات بالتحديد. بداية let's talk about particle fluence. شو يعني particle fluence؟ أول بارامتر بدنا نحكي عنه. بداية the particle fluence, so it's a measure used to quantify the number of particles passing through a given area in a radiation field. So it quantifies, it provides information about the number of particles passing through a given area, through a specific area in the radiation field. شو هن الستبس لحتى نعمل calculation للparticle fluence؟ شو لازم نعرف بالبداية؟ هدول number of particles كيف بدنا نحددهم؟ How can these number of particles be determined at a certain point or at a certain area? هلا بالradiation field we choose a specific point in space. This point بنسميها إذا بدكم PR. This point is called PR. Where here at this point we want to measure the fluence within a radiation field. At this point we want to measure the fluence. So around this point P, we create a small surface area, as you see here in the figure. This is the point P, the point in red. This is point P, and this is we choose a small surface area, بنسميها DA, around this point P. We create this small surface area, DA, so that, or in such a way, that its plane is perpendicular to the direction of the beam. Look here at the beams. The beams are perpendicular to this surface area. So this perpendicular orientation ensures that we are only counting the particles that pass directly through this area. And this will simplify the calculation. بنشوف شو هدول البيمز which are the beams that are perpendicular to this surface area. من خلالهم we determine the number of particles that intercept the area DA. So we count the number of particles that intercept or cross this area DA. This is how we calculate the number of particles. Now, what if the particles, or what if we talk about the case of non-parallel particle directions, as you see here in the figure. So here, all the particle directions are parallel. However, what if the particle directions are non-parallel? So as you see here in this figure. This means that these particles come from various angles. So we have different angles. So in cases where where the particle directions are not parallel, a fixed plane. So here we choose also a fixed plane DA near a point P. However, this plane DA would not accurately capture all the particles. This would not accurately capture all the particles. This is because a fixed plane can only intercept particles traveling perpendicular to it. However, the particles coming from other angles would be missed. هلا to solve this problem, to address this, بدنا نغير شوي بالconcept to calculate the particle fluence. أكيد الهدف to calculate the particle fluence. To calculate the particle fluence in such a non-parallel radiation field. إذا عندي كيس مثل هيدي شو لازم نعمل؟ بغض النظر عن ال particles angle of incidence فينا نعمل شغلة. We allow the surface dA, هيدي ال surface area يلي اخترناها, we allow this surface to rotate freely. So the plane dA is allowed to move freely around the point B, so that to intercept each incident ray perpendicularly. هيدا الحل. لهيك بنصير نحكي هون بسفير. So we can, if dA is moving around P in all directions, this essentially forms a spherical surface around the point P. So by creating a sphere around the point P, the area dA can intercept particles from any direction. So particularly, this means that we generate a sphere by rotating dA around P, and then we can count the number of particles entering the sphere. This is how to calculate the number of particles entering a sphere in the case of non-parallel particle directions. هلا صار فينا نحكي عن البارتيكل فلوينس. هلا ببعض الاحيان بنسمي هيدا البارامتر او هيدي الكوانتيتي فلوينس، يعني فينا نسميها فلوينس، فينا نسميها بارتيكل فلوينس. So the ratio between the number of particles and the area is called the fluence. This is simply the definition of this quantity. The fluence is the quotient dn over dA. dn هي number of particles incident on a sphere of cross-sectional area dA. فإذا the ratio between number of particles and the area هي الفلوence. So the unit for fluence is particles per square meter, number of particles per square meter، أو نحن عادة كيونت بنستعمل m-2، so meter minus 2. Here we have some notes. A note here is displayed in this slide. So this note tells us that the particles counting or included in phi may have any direction, but correspond to one type of radiation. So the particles counted can come from any direction. However, here the fluence is specific to one type of radiation. For example, photons يلي هن light particles and electrons are counted separately. This results in distinct values for photon fluence and electron fluence rather than combining them into a single fluence measurement. So this is an important note. فإذا الفلوينس بتعطيني quantitative measure of the particle density incident on an area, a specific area, and this allows to understand how many particles of a specific type interact with the surface in a given radiation field. How many particles of a specific type. يعني ممكن نحكي عن photons، ممكن نحكي عن electrons or other particles or other types of particles. How many particles interact with the surface in a given radiation field. Another parameter Another parameter is the planar particle fluence. بعدنا من particle fluence بس في شيء اسمه planar particle fluence. شو بيفرق عن البارامتر الأول؟ So it refers to the case where the area dA is not perpendicular to the beam direction. So as you see here, the beams are not perpendicular to the surface area. So planar particle fluence is the number of particles crossing a given plane per unit area. هذه الديفينيشن ذاتها. ولكن the planar particle fluence depends on the angle of incidence of the particle beam. بما أنه الانجل is not 90 degree,